Hello, welcome to your lesson on quadratics in vertex form. As you know, we've been talking about quadratics in three forms. There's this form called standard form, there's this form called vertex form, and this form called intercept or factored form. We've already done a lot of work from standard form to intercept form. Every time we factor, we do that. This lesson is going to look at vertex form, what it means, what the h and k represent, and also how to change vertex form to standard form. This lesson is going to involve an exploration. You're going to need Desmos, so open it now. You're going to do some exploring there and seeing if you can notice some patterns. So in Desmos, we are going to add an equation of the standard form, of the vertex form equation for a parabola, which looks like this. So let's enter that into Desmos now. So vertex form parabola looks like this. Y equals a parenthesis x minus h squared and then plus k. Make sure you've entered that in and then hit all so that your a, h, and k values all become sliders. So there we see a parabola. Now it says keeping a equal to 1, change the values of h and k, observe what happens. So I'm going to keep a at 1 here. We already know that a changes how wide or narrow a parabola is, or whether it is concave up or down. So we'll leave that for now. Let's change h and k. Let's begin with h. Well, that's pretty simple. When I'm changing h, I see the parabola going left, right. When we talk about moving things on a coordinate plane, this is called a translation. When we slide a graph, it is called a translation. So we're translating this horizontally, left and right. More specifically, there's a key point that's shifting. What point is that? Well, that point is the vertex. We can mark the vertex here. Notice the vertex is at 3.41, and notice the h value is 3.4 right now. Okay, now I'm going to go here. Notice the vertex here is at negative 1.51, and the h value is negative 1.5. So h clearly has some kind of effect like that. Let's go back here. So explain the effect of changing h. It can be said like this. H represents the x value of the vertex. Changing the h translates the parabola horizontally. One important thing to notice is we have a negative in this equation. So the h value, what occurs on the graph, for example, the vertex x value is the opposite of what we see here. If we had negative 2 here, our vertex x value would be at positive 2. If we had plus 3 here instead of negative h plus 3, then our x value of the vertex would be at negative 3. Okay, let's look at k now. So I'm going to set the h to be at 0, so the parabola sits right here, right in the middle. Alright, now let's change the k value. Oh, interesting, k value moves it up or down, but we already knew from before that that's what the c value does. And it changes the y-intercept, right? So let's move this one over a little bit like that, and now let's move it up and down. Okay, that's also moving it up and down. So what's going on here? What point in specific is being affected by the k? Alright, it's the vertex, just as before. So I can mark it here. We see 2.8, and that's what our h is, but now we're looking at k. I see a negative 1.6, and I see a negative 1.6 here. Now I'm going to slide this up. Now let's look at where the vertex is. Still at 2.8 because h remained there, but the k is what I just shifted, and k is 2.5, and here we see 2.5. So it looks like k affects the y value of the vertex, whereas h affects the x value of the vertex. So it's just the vertex that's moving around here, and h and k are changing those values. Great. Okay, so explain the effect of changing k. K represents the y value of the vertex. Changing k translates the parabola vertically. So again, translation means sliding it, vertically means up and down. So what part of parabola do h and k represent? Well, that's pretty clear now. hk is the vertex of the parabola. So Obviously, this is called the vertex form for a reason, because this form of writing a quadratic equation or a parabola clearly shows us what the vertex will be. It's these two values here that will tell us the vertex. Okay, so considering what you just learned, for each vertex form quadratic, state the vertex. So looking at this one, what is the vertex? It's negative 3, 5. I hope you didn't put 3, 5. Remember that key point, that the sign you see here with the x, the vertex x value always becomes the opposite of that. So we saw positive 3, it's going to be negative 3. The y one, however, the k value, tells us exactly what the y vertex value will be. Okay, what's the vertex of the next one? Alright, negative 1 from here and negative 4. What's the vertex of this one? 2, 7, and the last one, 7, negative 1. Great, now that you've got the hang of that, let's look at the next step here. Change each of these to standard form. So how do you take this one, change it to standard form? And then when we know what's in standard form, we know we have this formula negative b over 2a to get the vertex. So if we change to standard form, we can use that to confirm or verify that this vertex is the same one we have here. So to change the standard form, all you do is expand. We have this x plus 3 squared, which means x plus 3 times x plus 3. Multiply that, you get x squared plus 3x plus 3x plus 9. I'm showing all the steps here, but I hope at this point you don't need to show all these steps as you're expanding something like that. Okay, we still have the plus 5 at the end. Don't forget it's there. This 3x can combine to be 6x. I still have that 5 floating there. Now combine the 9 and the 5, and we get 14. So again, maybe for you it's easy enough to take that in your head, do this multiplication, and combine it all. Okay, using the negative b over 2a formula, we did negative 6 over 2 times 1, which is a, so it gives us that. That gives us negative 3. We can already see this x value of the vertex from standard form matches the x value of the vertex we got from vertex form. We see negative 3, negative 3. Now to find the y value from standard form, you can substitute this x value in here and calculate for y. So negative 3 squared is 9. Okay, so when negative 3 goes in there, we get 9 minus 18 is negative 9 plus. Okay, when we substitute that negative 3 back in here, we get the 5, and then we can fully confirm the vertex is negative 3, 5, as we saw from the vertex form. Okay, with the next ones we won't take as many steps. We'll just change to standard form and confirm the x value using negative b over 2a to see if it works. Okay, so in the next one, that change to standard form is this. Check your algebra carefully using these steps if you didn't get the same. And then we're going to use negative b over 2a, so negative 2 over 2 times 1 equals negative 1. That's negative 1. So it matches the vertex x value we had here. We can put that into here to verify the negative 4, but by knowing negative 1 is the same, we know the other one's going to work out the same as well. Okay, third one, change to standard form. That one in standard form looks like this. Check your work if you need to. And using negative b over 2a, we have 4, negative 4 is 4, over 2 times 1 is 2, makes 2. We can see that x value of the vertex produced by this little formula matches the x value here. And final one. This one in standard form looks like this. Using negative b over 2a, we get negative 14, which is 14 over 2 times 1 is 2, 7. X value of the vertex is 7 according to that formula, and we can see it matches what we got here. So it's good to see everything works both ways. So we're expanding our look at quadratics from just standard form now to vertex form and starting to understand these more. Okay, so based on all that you've discovered so far, with a vertex form equation where a equals 1, we're going to assume a equals 1. Let's write a vertex form equation for each of these. But before that, let me go back to Desmos for a second. Okay, that's not the one I need. I need this one. Okay, so we already know that h and k changes the vertex values, right? H changes the x value, k changes the y value. And then I just want to show now, going to a, that a does what we know it always does. It makes the parabola either narrower when we make the a values larger, or wider when it's a value between 0 and 1. See how it's at 0.5, it's quite wide. And then when a becomes negative, it's concave down, and also as the negative values get bigger, it becomes more narrow. So A has the same effect. So know that a vertex form quadratic can have an A value in front, and that A value has the same effect that we saw with standard form. Okay, so back to here, it says don't worry about the A value for now, because if we know the vertex, there can be many parabolas with that vertex. Wide ones, narrow ones, right? There's our infinite parabolas with that vertex. But we're looking for just that specific one where A equals 1. And this basically just practicing that you know what to do with the vertex. So what will be the vertex form equation for this one? Okay, it will be like this. All right, so there's vertex form. We have like that form where we have the x thing here, the y thing here, and the vertex tells us positive 2, that this is going to be negative 2 here, and positive 1 there, that's going to be a 1. Okay, what's the vertex form equation of this one? There it is. Okay, that negative 3 becomes 3 here, and we have a 4 here. Next one. That's that. Okay, hopefully by this point you're getting the hang of this. It's pretty simple. How about this one here? Okay, vertex, now the x value is 0, so I can write it there, but notice when you have a 0, you don't need it there at all. You can just write it like this. It just becomes x squared plus 3. So make sure you see that connection there. That means the vertex is, yeah, anyway, the x value is 0. How about this one here? This one begin the same way. We have our x value, our y value. We don't need to write that, so we can simplify it like this. And last one, vertex at 0, 0. That one looks like this. We have 0, 0, therefore simplifies just to x squared, because this is 0, so x squared. So that's your basic parabola. That makes sense, because a vertex at 0, 0 means a vertex at the origin, and that means that vertex has not moved from that origin at all. For example, here, if we made h 0 and k 0, notice the vertex is at 0, 0. It's at the origin. The parabola hasn't moved. We can make it wider or narrower using A, and then we can start moving it once we change the h and k values. Okay, with all that in mind, let's try this problem. So let's look at vertex form, and let's concentrate on the A value for the next little bit. So we have these 6 problems here, 6 quadratics, and you're asked to give the vertex of each and to tell us whether it's concave up or concave down. So in this case, the A value is important. Look at the first one. What is A equal to? And is it concave up or concave down? Well, in the first one, our vertex, they didn't ask about that. The vertex is at 3, 1. And A equals 1, because we don't see any number in front of there. That means that is a 1 in front there. A is 1. That therefore, positive A value gives us a concave up parabola. How about number 2? In number 2, the vertex is at 4, negative 3. Our A value is negative 1. Therefore, it must be concave down. How about number 3? In number 3, the vertex is at negative 1, negative 1. An A value of 2 tells us it will be concave up. And now do the same thing for 4, 5, and 6. Okay, great. Last question. Let's get back into Desmos, so make sure you're in Desmos. And we have this question. Your goal is to take this parabola, which is in vertex form, and flip it upside down. So this one is concave up. Can you make it concave down, but keep the same x-intercepts? So see if you can do that experiment in Desmos for a moment. Okay, and now Vlad argues that you just have to make A negative. He says just make A negative like this. A was positive 1 here, he made it negative 1, because we know that will make a parabola concave down. So will that work? Will that make it upside down but keep the same x-intercepts? Whereas Olga argues you have to make the entire function negative. So it will be written like this, and by entire function we mean take that whole thing and apply negative to that whole thing. So negative will apply to here, but negative will also apply to here. It's like multiplying the whole thing by negative 1. So notice this became negative just like Vlad's, but her negative 2 became positive 2 because she applied the negative to the whole thing. So maybe experiment with both of those and see who is right, who's wrong. Great, you are now ready for the next video. So great job learning about vertex form parabolas. I hope you understand what h and k are. They are the vertex, and that the A does the same thing it did for standard form. Please start the next video now.